I hope you had a go at that challenge. Pretty much what we want to do is first of all create our 3 spheres. So I'm going to go ahead, create a mesh instance 3D here, assign that mesh to be a new, new sphere. We can then duplicate that and make 2 more on either side. There we go. So now that we have our spheres, we then need to create materials for them. So inside of our materials folder, I'm going to right click on it, go new, resource. I'm going to go down to where we have standard material 3D, and I'm going to call this one pink ball. Okay. Now for our pink ball, we can click and drag on that sphere. As you can see, it doesn't really change much since the default material is very similar to the one that gets assigned when we actually create the mesh. But we can click and drag it on. We can then go over to the inspector, change the albedo color here. I'm going to make that a nice vibrant pink, something like that. And we can then change the roughness. Actually, no, keep the roughness at 1. I reckon. I think that's going to be a good idea. There we go. Now we can move on to the second ball, and this is going to be transparency. So I'm going to right click on materials folder, go new, resource, standard material 3D. I'm going to call this one blue transparent. Okay. Or technically translucent. So I'm going to click and drag on the center one here. We can then go in the inspector down to albedo. Let's just give our ball its blue color real quick. There we go. And then we can go over to the transparency drop down here. And right now transparency is set to disabled, so we want to click on that drop down and change it to alpha. Now what we can do is go back to our albedo, open up that color again, and you'll see here we have our RGBA values, red, green, blue, and alpha. And alpha is basically transparency. So we can click on drag on that slider to bring that down in transparency, as you can see here. And now if we pan our camera around, we can actually see through our ball. Now with transparency, there are a bunch of different types of modes for transparency. So if I click on the transparency drop down again, you see we have alpha, alpha scissor, alpha hash. So if we go alpha hash, for example, you can see that it basically has this solid blue mixed with totally invisible, okay? So it gives the appearance of transparency. And depending on, the rendering situation, it may be better performance for your game to do it this way. But I'm going to switch that back to alpha. We also have our blend mode, which basically determines how it renders the transparency based on what is behind it. So if we go add, that means it's going to add this blue color to whatever it is behind. Subtract subtracts it. So as you can see, it has this weird looking effect right here. And multiply is multiplying the colors together. Okay, so that's going to make it a bit darker. But typically, mix is what you were looking for the blend mode. Now, for our final sphere, we are going to be applying a texture. So I'm going to right click on materials once again, go new, resource, standard material 3D, and I'm going to call this one our texture ball. Okay, click and drag on the sphere. And to apply a texture, what we need to do is go down to where we have albedo, and you'll see here we can of course change the color, but we can also assign a texture, and that is going to be the flat color texture for our ball. And for this, I'm just going to be using our player sprite, so we can just click and drag that in here, and there we go. So as you can see, we have our player right here. We can even click on the color property, and we can actually modify the color that is sort of being multiplied by the texture, okay? So if we want the texture to look more blue, we can do that. If we want to make it look more red, we can change it to red. Okay, and that is pretty much the basis of materials inside of Godot. Once again, there are a lot of different settings here for you to change, and I just hope that you go ahead and experiment with these, as you can create some pretty interesting looking materials for your games. So thanks for watching. Hey everyone, in this lesson we are going to be looking at lighting inside of the Godot engine. Okay, now when working in 3D, lighting is very important as it sets the mood and it sets the theme of your game. So how do we create lights inside of Godot? Well, first of all, let's get an actual mesh in here so we can see what effect it has on the actual environment. So I'm going to click on the plus, I'm going to create a new mesh instance 3D, and we can change that to be a sphere. Okay, there we go. So we've got our mesh here. Now let's go ahead and apply some lighting to it. Now, if we click on the plus and we search for it, so I'm going to click on the plus, I'm going to create a new mesh instance 3D, and we can change that to be a sphere. Okay, there we go. So we've got our mesh here. Now let's go ahead and apply some lighting to it. Now, if we click on the plus and we search for light, you'll see there are 3 different types of lights we can create. We can create a directional light, an omni light, and a spotlight. Now let's start with directional light. So I'm going to select it and click create. Now a directional light is basically like the sun, okay? Our sun shoots down rays of light parallel to each other, and that's essentially what a directional light does. It casts a light in a single direction. So if we go to the rotate tool here with the directional light selected, you can see that we have this white arrow pointing in the direction that the light is being shone from. And you can see we even have a little sun up here in the skybox to show where it's coming from. And you'll see on our sphere here, the left-hand side is being hit by that light. And if we rotate this directional light, you can see how it changes the actual source or the direction of that light. Now, good thing about directional light is that it can be moved around anywhere in the scene, but the position does not affect where the light is coming from because it's basically coming from an infinite distance away. It's only the rotation that really matters when it comes to the directional light, okay? So you can see here we can modify our directional light rotation to modify where on the sphere it is being hit with light. Now, something else we can do with the light is many things actually. If we go over to the inspector and open up the light drop down here, you'll see there are a bunch of different settings we can change. For example, the color is, as it sounds, it's the color of the light. So if, for example, it's nighttime, you might want to have a bit more of a coldish blue light, so something like this maybe. Whereas if it's daytime, you probably want a nice, vibrant, slightly yellow-hued light, okay? And you can go ahead and modify those for whatever you wish. The energy, this is basically the intensity of the light, okay? And as you can see, if I bump this up, our sphere starts to pretty much glow if we increase the energy there. Whereas if we put it at 0, it's as if there is no light. So I'm going to bring that back up to 1. We don't really need to worry about the rest of these settings here since they are all for light baking and a much more complex lighting, so we're just going to ignore those for now. Okay, so we have our directional light. Now, what about those other
Yo, what's up, Thord? Hey, man. How you doing?
light types? Well, click on the plus, and let's create what's known as an OmniLight 3D. So we'll create our OmniLight, and with this, you'll see it has a sphere, okay, this wireframe sphere on the outside. And this basically is a light that emits from a single point in all directions, okay? You can think of it like a candle, a light bulb, okay? It has a source of the light and it emits in all directions. So what we can do is we can press W to go to our move tool. Let's move this light over here, and as you can see, it is lighting up our sphere.
Steel Hunter. Somebody had mentioned it to me, but I haven't looked at what it is yet, though. That sounds very interesting.
And this white wireframe is basically the range of the light. I mean, click and drag on this little orange node right here to basically change the range of that light. Now, to make things a bit easier to see, I'm going to go ahead and create a new mesh instance 3D. Let's set this mesh to be a plane, and that's basically like a solid ground. Let's increase that scale, move it down a bit. There we go. Okay, so we'll select the OmniLight again. We can move it around. To have a better viewing of it, to actually see what we are casting, let's change that light color over to, I'm going to change that over to a
Another mesh instance here. Plane. There we go. Okay. Plane is there. Let's change. Excuse me. Let's go back.
mesh instance 3D. Let's set this mesh to be a plane, and that's basically like a solid ground. Let's increase that scale, Move it down a bit. There we go. Okay.
Okay, so you just increase the scale. Let's increase the scale. Right. Let's reset that. And what if we move that? Move it over here. Watch some Naruto. Oh, nice, dude. Love it. What's your end goal with this? I'm just trying to get into it, man. Just trying to learn. Want to. I mean, right now, just immersing myself, trying to understand it. But like, I hope to build something small with it. I think eventually just release just a small game, so that way I can learn all the ins and outs of this whole process. The goal of making a big game at some point. I think that'd be really cool. But I've been on and off trying to learn this for a while. This is my first time trying to learn Godot. I tried to learn Unreal for a while, but Unreal is a beast. This is a little more friendly. Godot, yeah, Godot's free. This program is free. Yeah.
So we'll select the.
And Godot is open source, so like they don't take any percentage of the games you make, stuff like that. Like it's just an open source game engine. It's really light, so that's why I can run it on my crappy PC. Yeah, I mean it's nice.
The Omnilight again, we can move it around. To have a better viewing of it, to actually see what we are casting, let's change that light color over to. I'm going to change that over to we'll change it over to a red. Okay, we'll make a nice red light here. And we can then bump up the energy a bit, and we can then see how that affects our surroundings. Okay, now it might be a bit hard to see because of the white ground. So what we can do is select our directional light, and let's bring that energy down to 0. Okay, so now it's pretty much just our Omnilight shining here. And you can see we can change all the settings, the energy. Now, to change the range, we can open up the Omni drop down here and change the range. We also got the attenuation, which is basically the fall-off curve. Now, with lighting, we also have shadows. And so how do we apply those? Well, let's first of all set the energy of our Omnilight down to 0 for now, because we'll look at our directional light. Let's bring that directional light back up to 1. Now, how do we cast a shadow on this sphere onto the plane below? Well, to do that, we want to open up the shadow drop down here and just enable it. And there we go. It's pretty much done just like that. Same thing for the Omnilight. If we bump up that energy, we can go down to shadow and enable that shadow as well. And you can see there is a bit of a shadow cast here. Now, it is important to note that shadows do have some performance cost, but you shouldn't worry about that unless you have quite a few of them in your scene. Now, finally, we have one more light, and I'm just going to delete our Omni light here and delete our directional light. And that is going to be our, if we type in light, our Spotlight 3D. Now, Spotlight is pretty much as it sounds. It is a light that emits in a cone, okay? These would be good things for headlights, street lamps. If your character is holding a torch, a spotlight would be good for that. So I'm just going to rotate this spotlight so it's facing down. And you can see, if we zoom out here, that there is this white cone wireframe, which basically shows us the angle, which we can modify by clicking and dragging here, as well as the range. So we can modify those two things here. We can then change the light energy, so we might want to bump that up, like so. We can change the color, so let's change this to be a, we'll change this over to be a green, for example. There we go. And of course, just like with those other lights, we can apply shadows as well. And there you go. So yeah, that is just a quick look at these different lighting systems that we can use inside of Godot. We have the directional light, which acts like a sun. We have an Omni light, which acts as a light source that emits in all directions, like a candle or a light bulb. And then we have a spotlight which emits in a cone, and that acts as if it's a torch or a street lamp. So I'd recommend having a go experimenting with all these different lights, as really there is a lot to learn when it comes to lighting, so have fun experimenting with that.
Nice. If we want to simulate sun, what type of node would we use? Probably directional. How it will be rendered. OmniLight 3D. Checks in all directions, right? Yeah. Boom. Hundo. That's what I'm talking about. Oh, yeah. Very nice. Very nice. Just hurt my eye. Ah. She got like sand in my eye or something. I don't really know. Okay. We can just. What was that? Hmm. Like my contact just got scratched or something. Just instantly. I got like an eyelash in it. Oh my god. That is hurt. That really hurts, Charlie. It's just my left eye. Oh, jeez. Source video. Actually, no, no, no. Add source scene. Oh, just face. Add that source. Jeez. That there. Turn off the filtered one. Ah, okay. Jesus Christ. Okay. My eye's feeling better. Thank goodness. All right. The only other thing we gotta add